performs calculations using specific values in a particular order. For this session, I am restricting only to few mathematical functions. The first one which I am going to talk about is ABS function, the absolute value function. This function is used to find the absolute value of a given number. This function converts a negative number to positive number while the positive number remains the same. The function takes only one argument. For example, here the argument is positive, the absolute function will be returning the same number as it is, whereas in the second case the argument is negative. So the function changes the negative number to and make it positive. The third one is again a positive number that remains the same, whereas the fourth one, which is a negative number, is changed into positive. Here, suppose if in cell A1, if a number -4 is entered, then the absolute value of A1 will return the value as 4. The second function is Sqrt function. This function is used to find square root of a given positive number. The function takes only one argument, which is a positive number. For example, in the first case, the Sqrt will return the square root of 25, which is 5. In the second case, the argument is 10 into 10, which is actually 100. So Sqrt will return the value as 10, which is the square root of 100. The third argument is in decimal, which is 0.25, and the square root of 0.25 is 0.5, which is written by the Sqrt function. The fourth case, the argument is a negative number and therefore the Sqrt function is giving an error. In the fifth case, the argument for the Sqrt function has another function within it, and it is absolute function, which is giving us a value of -81 as 81, and then Sqrt will work on 81 and will return the value as 9. Now supposedly in cell C1, if 49 is entered, then square root function, Sqrt function, will return the value 7, which is the square root of 49. The next function is array function. It is used to find the remainder of the division. The function takes two arguments. It returns the remainder when the first argument is divided by the second argument. Here, the first argument is a division and the second argument is a divisor. For example, when 25 is divided by 3, the remainder left out is 1, and thus the function is returning the value as 1. In the second case, 21 is a multiple of 7, and thus the mod function is returning the value as 0. The third case, the dividend, which is 5, is smaller than the divisor, and thus the mod function is returning the value as 5. In the fourth case, we have a decimal in place of dividend. So here, that 15.5 is getting divided by 3 and leaving the remainder as 0.5. The next one is int function. It is used to round off given number to the nearest lower integer value. This function takes only one argument. In the first case, the argument is 7.8, which appears between the two integer values 7 and 8. Out of that, 7 is a lower integer value, and thus the int function is returning the value as 7. In the second case, the argument is 7.1. Again, this number is appearing between the same two integers 7 and 8, and out of which 7 is the lower integer value, and thus the int function for the second case also returning the value as 7. Now in the third case, the argument is negative, -7.8. This -7.8 appears between the two integer values -8 and -7. Out of these two, -8 is the lower integer value, and thus the int function returns a value as -8. The same is applicable for the fourth case also. In the fifth case, the argument itself is the integer value, so int function returns the same number. In the sixth case also, the argument is the integer value, and thus the int function is returning the same value. The next one is a round function. This function is used to round off the number given in the first argument to specify number of digits given in the second argument. For example, in the first case, the number 17.18256 is round off up to 3 decimal points, thus it is returning the value as 17.183. In the second case, the same number is rounded off up to 2 decimal points. Now let us see the fourth case, where the number is rounded off to the nearest integer value, which is 17. In the fifth case, the number is rounded off to the nearest 10th place value, which is 180. And in the last case, the number is rounded off to the nearest 100 value, which is 200. The next one is round down function. It rounds a number given in the first argument down towards 0. This rounding off depends on the specified number of digits given in the second argument. For example, in the first case, the number 17.18256 is rounded down up to 3 decimal points. In the second case, similarly, it is rounded down up to 2 decimal points. Now let us understand the fourth case, where the same number is now rounded down up to 0 decimal places. Now this number 17.18256 is appearing between the two integer values 17 and 18, and the one which is towards 0 is 17, and therefore the round down function will return the value as 17. For the fifth case, the rounding down of the number will be done to the nearest tens value. Now this nearest 10 value will be the one which is towards the 0, and thus the round down for the fifth case will be returning the value as 170. Now for the last case, the number is appearing between the two hundreds, which is 100 and 200. Now out of those 200, the one which is towards 0 is 100, and thus in the last case, the round down function is returning the value as 100. The next one is a round up function. It rounds up the number given in the first argument away from 0. This rounding off depends on the specified number of digits given in the second argument. For example, in the first case, 17.18256 will be rounded up to 3 decimal points. The second and the third cases are the similar ones. The fourth case we will discuss. In the fourth case, the number 17.18256 will be rounded up to 0 decimal points. Now the 17.18256 appears between the two integer values 17 and 18, and out of them 18 is away from 0, and thus the round up function will return the value as 18. In the fifth case, the number 177.18256 will be rounded up to minus 1 decimal points. So it is going to look for the nearest 10 values, which are 170 and 180, and out of these two nearest tens value, 180 is away from 0, and thus round up function will return the value as 180. For the last case, the number is going to look for the nearest 100 values, which are 100 and 200, and the one which is away from 0 is 200, and thus in the last case, the round up function will return the value as 200. The next one is the floor function. It rounds a number given in the first argument down towards 0 to the nearest multiple of number mentioned in the second argument. For example, here the first argument is 25 and the second argument is 4. So the multiples of 4 are looked upon. Now 25 is appearing between the two multiples of 4, that is 24 and 28, and the floor function is going to pick up the value which is towards the 0, which is equal to 24, and thus returning the value as 24. For the second case, the multiples of minus 4 are looked upon. Now minus 25 is appearing between minus 24 and minus 28. Out of these two, minus 24 is towards 0, and thus the floor function returns the value as minus 24. In the third case, we are going to look upon the multiples of 2 covering by 5.5, which are 4 and 6. and the one which is towards 0 is 4, and thus the floor function returns the value as 4. For the fourth case, the multiples of 3 will be looked upon, which are covering 7.5, and they are 6 and 9, and the one which is towards 0 is 6. In the fifth case, similarly, the multiples of minus 3 will be looked upon, which are covering minus 7.4, and they are minus 6 and minus 9, and the one which is towards 0 out of them is minus 6, and thus the floor function returns the value as minus 6 for the fifth case. For the sixth case, the multiples of 1.1 like 1.1, 2.2, 3.3 will be looked upon. Now this 2.5 appears between the two multiples, that is 2.2 and 3.3. Out of these two, 2.2 is towards 0, and thus the floor function for the second last case is returning the value as 2.2. And for the last case, the multiples of minus 1.2 will be looked upon. The multiples of minus 1.2 are minus 1.2, minus 2.4, minus 3.6, and so on. Out of them, minus 3.4 is appearing between minus 2.4 and minus 3.6. Now out of these two, minus 2.4 is towards 0, and thus for the last case, the floor function returns the value as minus 2.4. The second last function for today is ceiling function. This function rounds up the number given in the first argument away from 0 to the nearest multiple of number mentioned in the second argument. For example, here we are again similarly going to look upon the multiples of second argument. Here for the first case, the multiples of second argument covering 25 are 24 and 28. Now the ceiling function is going to pick up the value which is away from 0. Now in this case, the value which is away from 0 is 28, and thus the ceiling function is returning the value as 28 for the first case. In the second case, the minus 4 multiples will be looked upon, which will be covering minus 25, and they are minus 24 and minus 28. Out of them, minus 28 is away from 0, so ceiling function will be returning that as the value for the second case. Now in the third case, the multiples of 2 will be looked upon, covering 5.5, and the one which are covering 5.5 are 4 and 6. Out of these two, the one which is away from 0 is 6, and thus the ceiling function for the third case will return the value as 6. In the fourth case, the multiples of 3 will be looked upon, which are covering 7.5, and they are 6 and 9. Out of that, 9 is away from 0, so the ceiling function will return the value as 9. The fifth case, the multiples of minus 3 will be looked upon, and they are minus 3, minus 6, minus 9. Minus 7.5 is coming between minus 6 and minus 9, and minus 9 is away from 0, and thus in this third last case, the ceiling function is returning the value as minus 9. Now for the second last case, 1.1 multiples are 1.1, 2.2, 3.3, and so on. Now the one which covers 2.5 are 2.2 and 3.3. Out of that, 3.3 is away from 0, thus in the second last case, ceiling function is returning 3.3 as the value. And in the last case, the multiples of minus 1.2 will be looked upon, and they are minus 1.2, minus 2.4, minus 3.6, and so on. And those which cover minus 3.4 are minus 2.4 and minus 3.6. Out of them, the one which is away is minus 3.6, and thus in the last case, ceiling function is returning the value as minus 3.6. And the last and very important function that we are going to see is sum function. It is used to add numbers in the range of cells. Suppose in the range of cell, if there is a text entry, the sum function ignores the text entry. But if the text is entered directly in the argument of sum function, the sum function gives an error. Now let us understand the sum function with some certain examples. Now supposedly if some data is entered in this Excel sheet, then the sum function, if range is considered as A2 to A4, which is purely of numbers, the sum function simply is taking the total of 50, 20 and 30 which are entered from A2 to A4 and giving us the total as 65. Now suppose for the second case, if the range is considered from A1 to A4, which contains one of the text entry as marks, and then after there are numerical entries. Now in this case, the sum function is going to ignore the text which is entered in cell A1 and it is going to just sum up the numbers from A2 to A4. In the third case, the sum function is going to take up the total from A2 to A4, which is purely numbers, and also with that it is going to add the number 10, giving us the total as 75. In the fourth case, the range for the sum function is considered as B1 to B4. Now this range contains certain texts which are entered in B3 and B4. Now the sum function will be ignoring those two text values and summing up only the two cell values where the numbers are entered, that is B1 and B2, and giving away the total as 46. In the fifth case, the sum function has the arguments directly given in the sum function and the sum function is simply totaling those numeric values and giving the total as 65. Now for the last case, certain text values are directly entered as an argument. Now in this case, the sum function is not just going to ignore those text value, it is in this case going to give us the error. So here we are ending with our session.